Okay, welcome back. We're in the second video in this three-video series related to the unit on attention. And we're talking about attentional system one, also called as input attentional system. So the outcomes for this unit include, or video include, we'll talk about attention one, the input attentional system in general first. Then we'll talk about the six meanings we have put together under this umbrella. First, we'll talk about alertness or arousal, and then we'll talk about orienting reflex, then we'll talk about spotlight attention in that order. Let's talk about attention system one in general first. It's also called input attentional system. Now, to differentiate from the conscious or control attentional system, input attentional system is a basic process. It's quick and it usually is unconscious. In other words, it happens without your knowledge. It is related to situations that grab your attention. So the main reason for one way to think about attention system one is the immediate response system, so that you can take the information into your system and then decide whether it needs your conscious attention or not. In that sense, attentional system one is more data driven. It is dependent on the changes in the environment, the stimulus. So data is specific to the stimulus. So it's data driven or stimulus driven. You can also think of attentional system one more as a basic attentional process or a preparatory attentional process. A preparatory attentional process is where the system is preparing you. Attention system is one is preparing you so that you can consciously use the attention system two to decide whether or not it needs your conscious attentional resources. You'll consider it further processing through attentional system two if it is worth it. If not, then you just move on. So talking about the second outcome, which is nothing but the one of the three meanings of attention system one, which is alertness or arousal. So keep in mind that this alertness or arousal is basic, fundamental attentional state. It's a mental state of awareness. And if you're not aware, in other words, if you're not alert, then you cannot react to the changes in the environment. In other words, it is a necessary attentional state to be able to respond to the changes in the environment. Now, you can think about if you're not aware, right, then you cannot consciously attend to information. So, conscious processing or other attentional processing does not happen without this basic fundamental state. So alertness or arousal is the fundamental mind state, a state that keeps you aware of yourself and the surroundings around you. Now, I introduced input attentional system or attentional system one by using orienting reflex example. But what orienting reflex in specifically means is a quick reflexive response to an unexpected stimulus. If you suddenly hear a sound, did you hear that? You try to locate where the sound is coming from. You actually turn your head. You orient your head to the source of the sound to determine whether it is worth your conscious attentional resources or not for the sake of safety. So this sudden stimulus, an unexpected stimulus leads to a quick reflexive response. That is orienting reflex. Remember, it is a sudden part. In other words, if you hear this sound and if this sound continues and I'm talking, at that point, you will ignore this sound and just pay attention to my voice, right? In other words, you don't orient your head every time you hear a sound if it's a continuous sound. In other words, your system becomes unresponsive. It's called habituation. Habituation is unresponsiveness to a continuous stimulus. But you orient again if that continuous stimulus changes. Let's say if it stops or if it increases in speed, intensity, or decreases in intensity. So what is important for orienting reflex is this sudden unexpected change in the stimulus. So that is orienting reflex. So this brings us to the third input attentional process, the spotlight attention. Now, spotlight attention is like a spotlight. Just imagine you have the entire area, right? But this particular part on this area is under spotlight. Spotlight attention is this mental focus on a specific part in your visual field. Again, this is specific to vision. So this mental focus in specific part of the visual field is spotlight attention. Now, this is different from selective attention, where you're consciously selecting a part of the sensed information. In spotlight attention, you are expecting something in one part of your visual field. That expectation is spotlight attention. It is in some ways similar to Your orienting reflects that gaps your attention, but it is not in the sense that you're not turning your head. You're expecting something in a specific spot in your visual field. So there is a mental focusing, not a real movement, a mental focusing. Now, to really understand this, I would rather use an analogy or an experiment to talk about, and we'll do that in the next. So, Posner conducted experiments specific to visual attention. We're going to talk about one such classic experiment. The idea is very simple. The task in this experiment was for the participants to stare at the center of the screen. Usually, participants would be asked to stare at the center of the screen. Then this would be followed by a cue. A cue would be either a right arrow or a left arrow or a bidirectional arrow. When there is a right arrow, participants would be informed to anticipate an object on the right side, which is usually a square, although it's shown as a circle here, but it's usually a square. If the arrows they see is towards the left, then they can anticipate an object on the left side. Again, they're not allowed to move their eye. They have to stay at the center of the screen. The moment they detect an object on the right side, that's when they have to respond. So the task is respond to an object in the upper visual field while they were focusing, staring at the center of the screen. And before the object is presented, they were cued with an arrow mark that is towards the right or left or a bidirectional arrow. Bidirectional arrow means the object can be on either side. A unidirectional arrow suggests that the object will be on that side. But here is the trick. 50% of the trials, participants would experience a bidirectional arrow. Of the remaining 50% of the trials, 80% would be valid. In other words, if they see a right arrow, they'll see an object on the right side. If they see a left arrow, they'll see an object on the left side. But the key point is this 20% of the remaining invalid items. In other words, if the arrow is towards the right, they'll see an object in the left side. If the arrow is towards the left, they would see an object on the right side. So invalid. Okay. So again, they stare at the center of the screen and they have to kind of detect an object. When they do, they have to respond, and the time taken to respond would be measured. So the cue, the IV is the cue type, whether it's a valid, invalid, or a neutral cue. And we look at the results now. As you can see, the x-axis is the IV, which has three kinds of trials: valid trials, neutral trials, and invalid trials. Valid trials where the arrow mark and the object are in the same direction. Invalid when they're in the opposite direction. Neutral, it doesn't matter because it's a bidirectional arrow. What do you see here? The y-axis is the reaction time. Pause here for a second and try to interpret on your own. Well, you can see here that the reaction time for valid items is much faster than reaction time for invalid items. In other words, if you're cued that the object will be on the right side, and if you see an object on the right side, you're faster. But if you're cued to the right side, but the object is shown on the left side, then you're taking more time. Why would that be? Well, before we talk about why would that be, why it would be, let's talk about these constructs. Benefit. Facilitation or benefit is a faster reaction time to valid items. And opposite of that is cost. A cost is a slower response time to invalid items. Now, what is the reason for a slower response time? Now, just imagine if the cue is a left arrow and if you see an object, you're anticipating an object here. So the moment you see an object here, again, you're not looking at this part, you're looking at the center of the screen, you're kind of anticipating object on the left side. The moment you detect it, you'll say yes. So it will be quicker because you're anticipating it. So spotlight attention is this mental anticipation. Remember, you're not looking at this. It is the mental anticipation. You're mentally highlighting this spotlight attention. You're highlighting this part and expecting it, not visually, not actually looking at it. You're expecting that. That is spotlight attention. Now, why is it slower for the invalid items? Remember, if the cue was on this side, you're expecting an object here, but you saw the object here. For you to detect this object, you need to disengage from this one. In other words, your anticipation has to change, disengage, and re-engage on this part. That's why it is taking longer. So the invalid condition has slower response time because you have to internally refocus. Change your spotlight attention from this point to this point. You have to disengage, focus, redirect, and re-engage again. That's what is the reason why you see this big of a difference in reaction time. So the idea here you want to keep in mind about spotlight attention is your mental anticipation. It's like spotlight attention is kind of preparing you to encode stimulus in that particular point. Again, it's not visual in the sense that you're not looking at it, but you're expecting something there. I also want to kind of refer to the reading context. Just imagine you're reading a sentence. Posner's paradigm, you're reading a sentence. Right. Now remember we said that sensation, your eyes goes through fixations and saccades, right? So you fixate on this and you capture information and you attend to this information and you perceive and identify this as a word. Then the fixation is done. It goes to next saccade, right? The next saccade followed by a fixation. That's where you again sense information and attend to information, then perceive that as a word, right? Where does this particular spotlight attention fit? Well, your readiness to go from one word to another in this direction is spotlight attention. It is anticipation to go in this direction is spotlight attention. Now, this would be different if the context were different. Let's say, I don't know if, correct me if I'm wrong. Let's say if you have an Arabic book and you're reading, right? If I'm not wrong, they go from right to left, right? Then the spotlight attention is in this direction. When you read this word, your spotlight attention prepares you to go to the next word in this direction. So if you get a question, what triggers a saccade in the context of reading? The answer is spotlight attention, which is nothing but visual attention. So when you search for information in your visual field, the question is it serial or parallel? Now, what do you mean by searching for information in the visual field? Well, let's say you're searching for a green or a red object here, or you're just searching for a red object here. It pops out, right? In other words, you are searching for it in a parallel fashion. If you're searching in this particular box, right, for a green square, it slightly slows down because you're searching for two features. So what Traceman did is presented participants with single feature search followed by or a combined feature search. The first one is called a disjunction, where they'll be either asked to find a red object or a green object. Whereas here, they'll be asked to identify not only a green object, but also a square. So green and square conjunction, red or green is disjunction. And what Trisman found was that disjunction is faster than conjunction. When you're searching for one feature, it's faster. When you're searching for two features, it is very serial or slower. And according to Trisman, whether or not the search is serial or parallel depends on the surrounding information as well. For example, it's easier to find a red circle here than to find a red circle here, right? It's right here. In other words, the information pops out here, the information does not pop out here. So visual search, when it pops out, is more parallel. If information does not pop out, then you serially go through the searching process. So this brings us to the end of the second video in the 3-video series. In the next video, which is the last video for this series, we'll talk about the second attentional system, the attention system 2.